Welcome to my kcse Revision channel, my data channel Business School. And today we are looking at Form 1 work, that is water and hydrogen, the whole summary, and all the topics summarized in one page. Kindly follow my channel, click the notification bell, subscribe, click the notification bell, get notified once I upload a new video. Today we are looking at Form 1 work. And with me here you can see a whole summary of Form 1 work, the whole topic, that is water and hydrogen. So in water and hydrogen we have the sources of water. Sources of water, for example, you can be asked to name some sources of water where we can have, we get water from the rain, we can get water from the wells, we can get water from rivers and lakes. There is also the chemical sources of water whereby the hydrogen can combine with oxygen and then therefore it can form water. So in Form 1, we have substances which can be burned to produce water and water. So, for example, there is a burning candle, a very common experiment. In most cases, a student will be asked to name the product formed when a candle burns in air. Normally, when a candle burns in air, there are only two products that you can get. So, when this candle burns in air, you will be getting two products, and the two products you can have is carbon dioxide, and then of course you can have water. So you are required to name the product formed when a candle burns in air. You just say that a candle burns in air to produce carbon dioxide and water. Let us look at this, the first experiment. The first experiment or the first diagram in water hydrogen. So we can have that this is a candle, then we have cold water, we have lime water. This lime water is normally calcium hydroxide. So this is the calcium hydroxide, and also we have the suction pump. So as I've said that when a candle normally burns in air, it produces CO2 and water. So the purpose of this cold water here, it is just to condense the water vapor or to condense the steam that we can have a liquid water. Then again you can see where there is a pan, this curve is panning, we have the funnel shape. What is the purpose of this funnel shape in this experiment? The purpose why we are using this the funnel shape in this experiment is just to increase the surface area for the carbon dioxide. Increase the surface area for the candles to burn in air. So the reason why we have this the funnel shape, it is to increase the surface area for these candles to burn in air. Once the candle burns, it produces CO2 and water. The purpose of this cold water, it is just to condense the steam such that we can have water. Then we have the lime water. The purpose of this lime water, it is to test for the presence of the carbon dioxide, whereby it forms a white precipitate. Now, you can also be required to name some gases which are in the suction pump. We have impurities or gases, the dusty particles. So, to the suction pump, we have various gases there. You can have oxygen gas, nitrogen gas, noble gases like argon, neon, helium. So, those are some of the gases you can have to the suction pump. Now, what is the observation being made during this experiment? In this experiment, you can see various observations. I have combined the experiment 1 and the experiment 2. In experiment 2, we have also a candle here which is burning the presence of a funnel shape. And I've said the reason why we are using the funnel shape is just to increase the surface area for the candle to burn in air. Then we have anhydrous copper 2 salivate. The anhydrous copper 2 salivate, it is testing for the presence of liquid water. And also you can have the cobalt chloride paper. The cobalt chloride paper are normally used to confirm. They are normally used when testing the chemical test of water. So sometimes you will be required to describe the chemical test for water. Normally there are two, whereby we are using anhydrous copper 2 salivate, then we have anhydrous copper chloride paper. Now, if you require now to give an observation which is normally made in this experiment, one, you can have the anhydrous copper 2 salivate, it turns from blue, it turns from white to blue. So we have this one is anhydrous. Anhydrous normally is a substance which does not contain water. So we have anhydrous copper 2 salivate, this one here, it turns from white to blue, indicating that the liquid formed is water. That is the one chemical test for water. Don't say that the copper 2 salivate changes. This one does not change. It normally turns from white to blue. So to confirm the presence of this water, it turns anhydrous copper 2 from white to blue. Then we have the anhydrous copper chloride paper, which is normally which is blue. So anhydrous copper chloride paper, it changes from blue to pink, indicating the presence of water. That is some observation that you can make when we have anhydrous copper 2 salivate and anhydrous copper chloride paper. Normally, this one are used to test for the presence of water, and they are the chemical test for water, a very important point that you are supposed to know. And then we have the lime water. What is the purpose of this lime water? We have seen that there are normally two products which are formed when a candle burns in the air. That is CO2 and water. So we have seen how water is being confirmed. You confirm the presence of water using anhydrous copper 2 salivate and using anhydrous copper chloride paper. To confirm the presence of the carbon dioxide, the lime water is normally used, which is the calcium hydroxide. And what is being observed here, there is a white precipitate which is observed in the lime water, indicating that the gas produced is carbon dioxide. So in that case where we have a lime water, the main observation you can see in this experiment, it is the formation of a white precipitate. And the formation of a white precipitate, it is because of the reaction between carbon dioxide and calcium hydroxide, which is of course lime water. So in the two experiments, that is normally a very simple observation you can make. We are saying that the use of the funnel shapes, it is to increase the surface area for the candles to burn in the air. The cold water, it is just to condense the steam. And then where we have anhydrous copper chloride paper, it will just change from blue to pink, indicating the presence of water. Then we have anhydrous copper 2 salivate. Anhydrous is a substance which does not contain water. So when we have a drops of liquid water on anhydrous copper 2 salivate, it normally turns from white to blue. And our foil right, it changes. That one, it is not acceptable. You just say it turns from white to blue. So sometimes also you will be required to name some gases to the suction pump. Some gases to the suction pump, normally these are the dust particles. And what are these dust particles? The dust particles you can have likes of oxygen, likes of nitrogen gas, noble gases, likes of argon, we have helium, and then we can also have neon. So those are some of the dust particles normally which goes to the suction pump. Now, there is another experiment here in water nitrogen. So we have a reaction of magnesium with steam. A reaction of magnesium with steam. In magnesium, in a place of magnesium, you can also use zinc metal. In a place of this magnesium, you can also use the iron metal. So the three metals can be used here, where we can have a magnesium metal, you will have zinc metal, you have the iron metal. They can be used in performing the experiment, the reaction of water, the reaction of steam with the metals. Now, in my case here, I have a reaction of magnesium with the steam. So, first of all, we have this is the magnesium ribbon. The magnesium ribbon, as you can see, it is coiled. This magnesium ribbon is normally coiled, and the reason why it is coiled, it is to increase the surface area in contact with the steam. It is increasing the surface area in contact with steam. And that is the reason why we can have this magnesium liquid. It must be coiled such that it can increase the surface area in contact with steam. There we have the sand. In this sand, we can also use the cotton wool. So this one you can also use cotton wool. Can also be used here. You talk of the cotton wool, and this one we are talking about wet cotton wool. So you have wet cotton wool, or you can have sand. Then we have heat. Of course, you can have heat here, and also you can have heat at the magnesium liquid. Now, we have the sand. From this experiment, you can generate the sand is heated, or you can heat the wet steam. And now there is a question which is normally being asked: give a reason why the sand or the cotton wool is heated first before heating the magnesium liquid. So why do we heat the sand first, or why do we heat the cotton wool first before heating the magnesium liquid? The reason why we are heating the sand first, or the magnesium, the cotton wool, first of all, initially there was an air in the test tube. Therefore, it must be dried out. And again, the magnesium or iron or zinc metal does not react with cold water, so we need steam. So, two reasons why they are heated first before heating the magnesium liquid. One is to drive out air that was originally in the flat in the test tube, and number two, it is just to generate steam which can react with the magnesium liquid. So, the reason why we can have to drive out air originally in the boiling tube. So that is one reason why we are heating the wet sand or the wet cotton wool before heating the magnesium liquid. And very important, this one is to generate steam which react with magnesium. So there is two reasons why we are heating this sand: to drive out the air originally in the flask, in the tested the boiling tube, and also to generate steam which can react with magnesium. A very important point to note, because as somewhere you will be required to give a reason why the sand or the wet cotton must be heated first before heating the magnesium liquid. Now you can also see that what hydrogen has collected here, so we can have the hydrogen gas which is collected over water. And the reason why the hydrogen gas is normally collected water, the gas is insoluble in water. So this one here you will say it is insoluble in water. So the gas is insoluble in water, and that's why normally it is collected over water like that. And it is hydrogen gas. Hydrogen gas is insoluble in water. So what are some of the observations that what are some of the observations normally made during this experiment? So one, you can see purples of a colorless gas which is collected in the gas chamber. So the purples of a colorless gas is collected here, and normally the purpose of this colorless gas which is collected there, it is hydrogen gas. Then again, when magnesium reacts with the hydrogen, react with the steam, you can have a white border. So you can have a white border of magnesium oxide. So we have a white border of magnesium oxide, which is normally observed at the test tube or the boiling tube. In this case, now you will have the magnesium combining with the steam. So we have the magnesium oxide and hydrogen gas. So this is normally the equation of the reaction which takes place when magnesium reacts with the steam. I said you can replace magnesium with the zinc metal. You can replace this magnesium with the iron metal. So even you will be required to give another metal which can be used in place of magnesium. In place of magnesium, you can say zinc metal or the iron metal. So simply that is an experiment to show the reaction of magnesium with the steam. Now, a very important also, we have this hydrogen gas. In this hydrogen gas, the reactions used for the preparation of hydrogen gas, methods of the collection of the gas, and also the uses of the gas. So those are some of the things that you are supposed to know about the hydrogen. Now, the hydrogen gas what are some of the reagents required for the preparation of hydrogen gas? So one reagent we can have a dilute hydrochloric acid and then it reacted with zinc granules. And some few drops of copper sulfate might be added here in this experiment to increase the rate of the reaction or to act as a catalyst. So in this case, you will have the dilute hydrochloric acid reacted with the zinc granules. So you have zinc granules here reacted with hydrochloric acid, then you correct the zinc chloride and of course the hydrogen gas. The hydrogen gas normally is collected here. The gas is collected over water because the gas is insoluble in water. So when the gas is required to dry, we have some of the drying agents. The reactions which are normally used to dry the gases. One of the reactions we can have the calcium oxide, we have anhydrous calcium chloride, and also we have the concentrated sulfuric acid. So in this case, hydrogen gas, if required to dry, the gas can be passed through a concentrated sulfuric acid, which is able now to dry the gas. So you can have the dry hydrogen gas is collected by the upward delivery, and the reason why it is collected by the upward delivery is because that the dry gas in this case it is less denser than air. So a dry hydrogen gas once dry must be collected by the upward delivery, or this method is also sometimes called the downward displacement of air. Because initially there was a gas inside here, so if the hydrogen gas is normally introduced here, the original gas that was here, it is displaced downward. And that is one of the other methods of the other name of this method is normally the downward displacement of air. So a dry hydrogen gas is normally collected by the upward delivery. Now, how do you test for the gas? So how do you test that the gas produced is hydrogen? So sometimes you will be required to describe an experiment to show that the gas produced is hydrogen. In this case, when you are required to describe an experiment, you need the apparatus, you need a gas chamber, for instance, which is full of that gas, a gas suspected to the hydrogen. You can also have a wooden splint, and also you give a smaller procedure. You give a smaller procedure that should be taken to show that the gas produced is hydrogen. Now, how do you test for hydrogen? Describe an experiment. Introduce a panning wooden splint. We just introduce a panning wooden splint. Introduce a panning wooden splint. This one here. It is a panning wooden splint. You need to understand this one very well. It is not a glowing splint. We are using a panning wooden splint at the mouth of the gas chamber suspected to contain hydrogen. Why do we say that the gas suspected to contain hydrogen? Because you are describing and you are testing whether the gas is hydrogen. So you suspect that that gas chamber must contain might contain oxygen gas. So you have introduced a panning wooden splint at the mouth of a gas chamber suspected to contain the gas, suspected to contain hydrogen gas. So what will happen? The panning splint is extinguished. The panning splint is extinguished with a pop sound, confirming that the gas produced is hydrogen. So that is simply how you can describe a very simple experiment, a very simple steps, very simple procedure on the test for hydrogen gas. Now, there is another experiment here whereby we have a reaction of this hydrogen gas with metals. Remember, hydrogen gas is a reducing agent, so it can reduce some metal oxides, it can reduce lead oxide to lead metal, it can reduce copper oxide to copper metal, it can reduce the zinc oxide, magnesium oxide, and so on. So here with me, I have an experiment where you can introduce a dry oxygen to lead oxide or copper oxide. What will happen here? Remember, hydrogen gas is reacting as a reducing agent. So if you introduce a dry hydrogen gas here, either you will have the copper oxide, you can have the copper oxide or the lead oxide. So what will happen? the lead oxide will be reduced to lead metal and water. So what are some of the observations you can make here? One, you can see a colorless liquid. You can see a colorless liquid in place where we have the lead oxide, whereby the lead oxide will be reduced to lead metal. So you can have observation of a colorless liquid, and this colorless liquid is water. And again, the copper, the lead metal, it is when it is the lead metal. This one here, this metal is yellow. So the lead oxide here, it is yellow. It is yellow when cold. So when you react with this one with hydrogen in the presence of heat, this one can be reduced to an orange metal. So it can be reduced from yellow to we have a yellow lead oxide metal to orange metal or gray metal. So and a colorless liquid here. If we use copper 2, the copper 2 oxide is normally in this case is black. So you can reduce by hydrogen to copper, which is a brown solid, and of course you can have the hydrogen gas. So you can also have another experiment where we have a dry hydrogen, then we have a copper 2 oxide, then we have anhydrous copper 2 oxide. Then you can also have the panning hydrogen there. So what do we have here in this case? There are some of the precautions or some of the things that we are supposed to know when carrying out this experiment. One, air is derived out. It is derived out of the apparatus to ensure that the hydrogen being part of the jet is pure. So give a reason why that the air must be derived out of the apparatus. You are supposed to give that reason. So the reason why the air is derived out of the apparatus, it is to ensure that the hydrogen plant at the jet here, this hydrogen plant at the jet here, it is pure to avoid explosion when in this case it mixes with air. Remember, a reaction of hydrogen with the air is very explosive, and that's why the air must be derived out of the apparatus to ensure that this hydrogen planting at the jet must be pure, and of course to avoid explosion when it's reacting with air. The supply of hydrogen must be continued while the apparatus cool. And while doing that, it is to avoid the oxidation of body metal by oxygen from the air. So those are some of the things that you are supposed to know when there is a reaction of the hydrogen with the metals. Now we have here there is to summarize this one here. You can see a diagram, the burning of a candle. Of course, we explained in our first diagram where we have the funnel shape. The funnel shape is it is increasing the surface area for the candles to pass in air. We have the calcium oxide. The purpose of calcium oxide in most cases it is used to dry the gas, or you can use the concentrated sulfuric acid. And also you can also have the suction path. So we have this is the suction pump. So what is happening there that sometimes you will be required to name some of the gases to the suction pump. And I said that these are normally the dust particles where you can have oxygen, neon, argon, and other gases. So you can also have the calcium chloride here. And the purpose of calcium chloride in this case is used to observe water vapor. Now, what are you supposed to know from this experiment? That when the pump is turned off, if the pump is turned off at this side here, if this pump is turned off, the candles goes off. So if the pump will be turned off, the candles goes off. Normally, why is it that? Because when the product of a candle is just CO2 and water. So CO2, carbon dioxide, does not support combustion. Water vapor does not support combustion. So if the pump is just turned off, there is an accumulation of carbon dioxide and water here, which does not support combustion, and therefore they cut off the supply of oxygen. Then eventually the candles normally goes off. And finally now we can also have the uses of hydrogen gas. So you can be required also to give the uses of hydrogen gas. hydrogen gas is used in large-scale manufacture of hydrochloric acid. Hydrogen gas can also be used as a raw material during the manufacture of ammonia in the HAPA process. It can also be used in welding, whereby when mixed with oxygen, it produces that very hot flame, we call it styrene flame. Oxygen can also be used as a rocket fuel. It can also be used in hydrogenation or the manufacture of margarine. So those are some of the uses of hydrogen. So these are very simple summary of manual work, and in most cases, a question you cannot miss from this part. Kindly follow my channel. You click the notification bell. You get notified once I upload a new video. Thank you.